O Flash Camp Brasil é realizado por Adobe e Action Creations. Patrocínio Platinum, BlackBerry Playbook. Patrocínio Prata, Velo Telecom. Patrocínio Bronze, Wacom, Influxes, Chambi, Reacycle, The Click. Apoio, Jornada Adobe, Tango, Alternativa Platform, O'Reilly, Abra Web, Rádio Jovem Pan, Faculdade Maurício de Nassau, Marca Viva TV, Linda.com.
Ele dirigiu o time de engenharia do Air, o Runtime de Multiscreen para aplicações desktop, dispositivos móveis e TVs. E antes da Adobe, ele trabalhou 10 anos na Apple e foi um dos responsáveis pela implementação do sistema operacional hoje, o Mac OS X. Então, com vocês, lá da Califórnia, Arno Gourdol.
Bienvenidos a Flash Camp Brasil. Bienvenue à Flash Camp Brasil. And welcome to Flash Camp Brasil. The rest is going to be in English, sorry. It's the best I can do. So now is the time to turn on your headsets. I'm very excited to be here today. I think we had some great presentations already. Very excited to see all of you here. It's really great. And I have a few things that I want to talk to you about today that I hope you'll find interesting, and I hope that you'll stay awake until the end of my talk, because it's getting late. So, like Damien said, my name is Arno Gourdol. I'm on the Flash Runtime team at Adobe. And I'm going to share with you some of the things that we are thinking about. And I want to make sure that I get your feedback as well. And that's the reason why I want to share some of those things, so that you can tell me whether you think that we're going in the right direction, or if there are some other things that we should be looking at. That's going to be an opportunity for you to tell us that. So this is going to have to be an interactive session. The way it's going to work is there's a number of things that I want to talk to you about that we're thinking about doing. If you like what I'm saying, if you like what I'm talking about, you're going to have to applaud, okay? If you don't applaud, we may not do it. So big responsibility for you guys here today, but you're going to have to tell me whether you think I'm going in the right direction or not. I'm also going to be talking about some things that we have never talked about outside of Adobe, so this is going to be a little bit of a first. Some of the technologies I'm going to talk about are almost already available, but some of them not at all. So again, tell us, now is a good time to tell us whether it's going in the right direction or not. I'm going to start with a quote from Wayne Gretzky, who was a very successful hockey player. And when he was asked, why does he think he's so successful? Why is he such a good hockey player? That's what he answered. He said, that's because I skate to where the puck is going to be, not where it has been. And what this means is that you really have to be thinking ahead, not just where the situation is currently, but what it's going to be in order to anticipate what's going to happen. Now, I know this is kind of weird. This is a hockey quote. And, how many of you play hockey? Exactly. So the thing is, it's the same situation with football, right? It's exactly the same idea. You have to anticipate, to think about where the ball is going if you're going to be successful. So whether I try to find actually a quote from a football player that said about the same thing. I could not find one. I looked around all over the place. I could not find one. But anyway, it's the same idea. So let's look at some of those things that we should be thinking about that gives us an idea of where things are going. The first one is a really interesting statistics about what's going to happen in the next year or two in terms of internet users. And we're soon going to reach this point where there's actually going to be more mobile internet users than there are desktop ones. And desktop, that means both desktops and laptops. Mobile, that's smartphones and tablets, essentially. So and those dates, by the way, have been evolving. It used to be that it was like 2015, and then it keeps getting sooner because things are actually going faster than anybody's anticipating. But regardless, it's going to happen really soon. Next year, maybe 2 years from now, there's going to be more mobile internet users than there are desktop internet users. So that's a really interesting change. What that means is that a thing that's going to be very important is going to be thinking about power consumption and battery usage. Because by definition, if you have a mobile device, you want to be able to move around with it. You want that device to be with you all the time. Those mobile devices are devices that are personal, that you carry along a whole day. So something that wasn't very important in the past, thinking about when you build content, when you build an application, how much battery usage what you built meant is going to become very, very important. So that's kind of a second thing worth thinking about. And then a third one is also the evolution of the hardware. There's some really interesting things going on right now where you see what used to be very low-powered devices, right? Typically, smartphones, or even before that, feature phones, tended to have very little computing power, very processors that were not capable of doing very much other than displaying maybe a contact list, and that was about it. But now we have this amazing hardware that's becoming available in portable form that has multiple cores, that has GPUs, that can do all sort of interesting things. And so the question becomes, well, how do we take advantage of all of that? If we have all this great hardware at our disposal, it is our duty to do the best we can to actually use that hardware and do some interesting things with it, right? So that's kind of like the third thing that's worth thinking about it, that's interesting. Now, another thing that's kind of interesting is that things used to be so simple. And that's not that long ago, right? Where you could think about, if you wanted to write an application or build some content, you just had to make sure that it worked on Mac and Windows, and you were kind of covered, right? That was it. That's all you had to think about. And that was true even less than 5 years ago. But since then, the whole environment has really changed, and what we've seen is this multiplication of other platforms, of other operating systems, some new ones that are coming up, some that may not stay around for very long, we'll see. But it's certainly making your life as a content designer and as a developer very interesting, because that means that all of a sudden you have to worry about all of those things if you really want to have the reach that you want to have and be able to get in touch with all your users. So we've been thinking about all those things, and our goal at Adobe is to try to make it as easy as possible for you designers and developers to build content and applications that you're going to be able to put in the hands of your users ultimately. So one of the things that we're doing to help with that is we're building what we call the Flash Runtime, which is essentially a Flash player in the browser and Air for standalone applications. And we're doing the work of making that runtime available on a lot of different platforms and environments. So we're available on the desktops, both PCs and Macs. We now have Air on TVs with the Samsung smart TVs. This year, all the Samsung smart TVs that will ship will actually have Air built in, so you can run Air applications on them. We have Flash Player on Google TV. And we're also available, of course, on mobile devices, whether that's on iOS, on Android, and now on the RIM Playbook. So we're very excited about that, and we're very excited about giving you the tools that allow you to build your content and then be able to distribute it to all those different platforms. Now, we want to be realistic about this as well. All those platforms are very different, and you don't interact the same way with a TV set than you do with a smartphone or that you do with a desktop. So when you build your content, when you build your applications, you'll have to tweak them You have to make sure that the user interaction is appropriate for the device that you're targeting. But as much as possible, we're trying to make the bulk of the work as easy as possible for you. This is the shirt that Damien is actually wearing. And that's one of the things that we like to say is that now we've put air for applications kind of everywhere. It's on all the devices that you want it to be. So that gives you opportunities to build applications that can target all those different devices. So with such an interesting environment that we are living in now, with so many things that are changing so quickly, new devices that are coming out, and new operating systems, new technologies, the ways that we used to have of building our software has to change. And it used to be that we were doing a release of Flash Player maybe every 12 or 18 months. But in 18 months, you can have a whole new generation of products that are out that you want to be able to target. So we're going to have to change that. And what we're going to do, starting with this year, we're going to start having releases of both Flash Player and Air 4 times a year. So that's going to be much more rapid paced than what we used to have. We'll have 2 of those releases, that's the big red dots, that will be bigger releases that will have more features in them. And then we'll have 2 smaller releases in between them that will be for small bug fixes, smaller improvements. But that means that we'll have at least 2 opportunities a year to introduce new features and new capabilities that you'll be able to take advantage of, and also that we'll be able to keep up with what's going on in the rest of the industry. So that's going to be really, really interesting. One thing I want to talk about, because I get this question a lot also, is about HTML and Flash, right? And why do they not like each other? Well, the truth is, it's actually not as bad as some people make it to be. There isn't really a fight between HTML and Flash. We don't think that Flash is good for everything and HTML is good for nothing. We think that HTML is great for some things and Flash is good for some things as well. The thing is that HTML is actually getting better and better, and it's a great thing. That means that you can do more and more things with HTML. And if you find yourself with a problem that you're trying to solve, and you can solve that problem using HTML, you should go ahead and do that. Don't try to make everything work with Flash when you can get something to work with HTML. Now the thing is that HTML is not, it depends on which part of HTML you need, and how important is it for you to have access to a lot of people, because especially the newer features of HTML are not available to everyone right away. So you have to think about that a little bit. But certainly very often that's going to be a very reasonable option. So the way we really like to think about things is Flash and HTML, and both of them have their place and their use. So obviously we're doing a lot with Flash, but we're also doing some things with HTML. One of the things that we've been working on is with some of our customers that are building digital magazines. And one of them that we've been working with is Condé Nast, who is the publisher of the Wired magazine. And they wanted to bring their publications to tablets. So we worked with them on that. We built software that allows them to repurpose the content that they've already built with InDesign and so on, and publish that for tablets. We built a nice software that allows you to do the navigation of the magazines and so on. But one of the things that we found out that was really interesting is that for magazine publishers, the layout is absolutely crucial, right? The stories are nice and the images that goes with it and so on, that's part of what you deliver. But the way things are laid out, especially for a magazine like Wired that has very sophisticated layout, that's a really important part of their brand and their image. And so they want to be able to preserve that when they go to digital magazines. And what they found out is that the easiest way of actually doing that was to just basically build an image that represents the page and display that. That was the only way for them to get really the kind of fine-grained control that they wanted to have. There's all sort of disadvantages with that approach as well, right? It means that you've lost the text in a way. The text is no longer selectable. You can't research the text. It's just images that you're looking at. So it's not an ideal experience either. But when the control of what you're displaying is that important to you, that's a sacrifice that you're willing to make. So we looked at this and we're like, you know, that's not great. Ideally, what you would want to do is you would want to look at some very sophisticated pages that you find, you know, in print that have all sort of interesting features, like having multiple columns and being able to have areas that are that have images that the text avoids, and all of that. And you want to be able to transfer that digitally, and you would want to use HTML to build something like that. But if you want to build something like that with HTML, today it's either really, really hard if you're really courageous, or impossible if you're, you know, more reasonable. So we want to change that, and one of the things that we're doing is we're working with we have some ideas for how, you know, CSS and HTML could work better to do this kind of thing. So we're working with some of the web standard groups to propose some improvements that will allow this kind of thing. And those are improvements that we're going to be contributing to WebKit as well. So it will be available open source for anybody else who wants to take advantage of it. Because we think that by doing this, by making the web better, everybody benefits. Our customers benefit, we benefit, everybody benefits. So it's a good thing to do. So we're doing a lot of work on Flash, but I wanted also to let you know that we're also doing some things with web standards. All right. So the rest of my presentation, I'm going to be talking about some of the things that we're doing with the Flash Runtime. I'm going to be talking about 3 areas. One is going to be ActionScript and our virtual machine. Another one is going to be about video, and the third one about graphics. And that's the portion where you're going to have to vote and tell me which ones of the ideas I'm going to talk about you think are good ones. All right, so let's start with the first one, which is related to our ActionScript virtual machine, and which is about having a faster garbage collection. How many of you know what garbage collection is? Let me start with that. All right, I'm going to give you a crash course in memory management. So the garbage collection, basically, one of the things that we try to do is when you build your content and your applications with ActionScript, we try to make it easier for you to do that than using some other tools. And one of the things that we're doing is we're managing the memory for you, which means that you don't have to worry about, you know, allocating memory and disposing of it and making sure that you don't have leaks and crashes and all of that. And we have what we call the garbage collector that does that for you, which is basically the piece of software that looks at all the memory that is getting allocated on your behalf and kind of figure out, you know, when something is no longer needed and can be disposed of. That's what the garbage collector does. Now, the way it does this magic is by looking at everything that's in use and from time to time seeing if something is actually no longer needed. And doing this operation from time to time, this garbage collection, is something that can take time. And the result of that can be, if you have something that's very interactive, for example, or that has a lot of things going on, you can see some little pauses that can happen at inconvenient time because there's a need to, you know, get some of the memory back. So we're looking at improving that, and the way we're going to be doing this is by implementing what we call an incremental garbage collectors, which means that we won't have to do everything at once and try to get all the memory back at once, but we'll be able to do it more incrementally. That way that will avoid having, you know, some big block of times where we have to go through all the memory and do the cleanup. We're also going to be working on reducing the allocation cost so that when you need to have memory allocated, that can happen like really quickly and more cheaply. And then another thing that we're thinking about is to give you more control also about the garbage collector and to decide when it's a good time to do a garbage collection, or maybe to tell us, you know, don't do anything right now. I'm doing something that's, you know, very interactive. For example, I'm doing a transition between 2 screens or something like that. something that's not necessarily going to last very long, but I want it to be like very smooth, and I want to have like really good interaction. So the idea with this is that we would give you some APIs that you could call that says, don't bother me right now, come back later to do the garbage collection, but I'm busy, so that you can kind of pause the garbage collection. So we're looking at introducing those APIs in a future release. And eventually where we want to be would be to build what we call a generational collector without copy, which means that whenever there's a need to clean things up, they would get cleaned up without anything having to be copied in order to do that cleanup, which is what happens sometimes. And of course, what that means is better performance and less interruptions when the garbage collection happens. So, what do you guys think? Is this something that you absolutely want to have? All right. That's good. You guys are excited about garbage collection. I like it. All right. So let me talk about some other thing that we have in mind. Maybe at the end, I don't know if the one I just talked about is going to be your favorite. There's a few others, that are coming. So we'll have to see. Another thing we're going to be looking at is making ActionScript faster, because the faster ActionScript is, the more you can do with it, obviously. So here are some of the things that we're thinking about doing. They're excited about garbage collection too. The JIT is what happens when you write your ActionScript and then it gets compiled to native code on the fly, right? Once the code for your application or content has been loaded in memory, before it gets executed, we turn it into machine language code that can be executed really quickly. We're looking at improving that and making it better by giving more information to the JIT about the type of the objects that needs to be compiled. So that's going to require us to change quite a bit about the way the JIT works, but that's going to allow us to do more optimizations as well. So for example, when you have code today that maybe makes an addition of two different numbers, there's no way for the JIT to know that those numbers are really numbers. Because ActionScript being a dynamic language, one of them could actually be a string and the other could be a number. And it's still going to work, but in order for it to work, that means that the machine code that we generate has to do a lot of checks and look at all sorts of different things before actually doing the addition, for example, of those two numbers. By having some of the type information with the JIT, that allows us to do those checks at the time that we're producing the code. And therefore, if we already know that those are really going to be two numbers, we can generate something that's going to be much more efficient. So that can really speed up the way that your code works. We can do some optimizations for all sort of numeric operations, which, again, if you look at the code that you write, a lot of the code that you write is about manipulating numbers, whether it's building a physics engine or doing some drawing or some rendering, you're always dealing with some numbers. And with this, we could have some better optimizations on all those operations. So that could be really interesting. And then there's a funny thing also that we can do, which is called nullability. And what that means is that whenever we generate the native code for your ActionScript, one of the things we have to do, again, because it's a very dynamic language and we can't really be sure of anything, before, for example, you access a property of an object, we have to check to make sure that the object is not nil. Right? So that's one of the things that we do for you is we make sure that your program never crashes. But the way we do that is by doing things like that, by always checking that everything is still OK and preventing you from doing something that would be bad. But that can be expensive. Now with this new JIT that we're working on, we're going to be able to keep track of whether an object is nil or not before we generate the code. And if we know it's not nil, we can just avoid generating all the checks for whether it's a nil object or not. So that can also speed things up really quite a bit. How do you guys like this one? All right. Wow, you guys really like it. That's awesome. All right, another thing you're going to be really excited about then, if you like this, we are working on introducing a new fundamental type to ActionScript, which we're going to call float. It's another kind of number. It's going to be a 32-bit IEEE number. The really nice thing about it is that it's going to be really, really fast. Because again, today, if you use the number class, it's an object. We have to do all sorts of checks and conversions before you can do any kind of operations on it, even just like adding something to it. With floats, you'll be able to tell us, I promise this is just going to be a 32-bit number and nothing else. And we'll be able to optimize and generate much more efficient code when doing this. And to make things even better, we're also going to introduce a new type that we call float4, which you're never going to guess, but is actually 4 floats in a row. So why would we do that? Why is 4 float interesting? Why not 3 floats or 2 floats? Well, let me tell you. 4 float is really interesting when you start to do 3Ds, because any kind of 3D operations is typically going to involve 4 floats to do some sort of matrix transforms or sort of interesting mathematical operations. By having this primitive type as float4, we'll be able to also leverage the hardware that very often actually can do multiple operations on floats at the same time. So again, that can give you big benefits in terms of performance. So that's going to be good for all kind of things. Like I said, maybe 3D, physics engines, even some simple things like collision detection in a game, for example. That's something that could benefit from all of those things. Okay, so who's excited about floats? You guys are awesome. You're going to get all the features if it keeps on going that way. I'm telling you. I don't know if we can afford it. All right. I'm building up. So this one, you're going to be really excited about. So again, this is something that we've never talked about before. This is a first. But yes, we are working on bringing concurrency support to ActionScript. Wait, I haven't even told you what it is. You guys are excited. Maybe that's something else than what you think. All right, I don't think so. All right, so let me give you a quick example of how we're thinking about it. First, notice the disclaimer in the upper right. Things could change. This is how we're currently thinking about it, but it could be a little bit different once we actually build it. So the basic idea of concurrency is that you can execute multiple Swifts, if you will, at the same time. So the way that would work is you create your new worker object. You create associated with an event to know when it's done. And then you say, OK, load it. And then you can pass some parameters to it. And then this is the worker Swift itself that does something super simple here. There's display hello with the parameter that it got back, right? So super, super simple. We try to make it really hard to do something wrong. Because when you use things like threads and locks and so on, it's so easy to build something that is either really, really hard to debug or has like some really weird bugs that happen almost never, but when they do, everything is locked up, or really bad things. So we're introducing this model to make it easy to get the benefits of multiple executions in parallel, but making really hard to do something that's going to break. So that's one example of how you can use it. And then here's another one. This one, instead of using a separate Swift, it's actually all in one Swift. But the difference here is that you just use a metadata to say, OK, by the way, this class right here that I'm declaring, it's going to be an entry point, meaning it can be called from another Swift. And then you can see pretty much here that's the same kind of code as the previous one. It works in a very similar way. One thing that's added in this example as well is that you have this worker connection here that you can specify, which is a way of sending more information to your worker. And what we specify here in this case is a talkback function. And that's going to allow you from your worker to call it back right? So that you can send information back and forth between the two workers. So this is modeled after net connection, so local connection. So it's a very natural way. It's almost like when you're running on your system, it's like you're talking to a little server almost, right? Except the server is actually running inside the same, with your application or your content, but it's using the same APIs and so on, the same programming model. So you're just sending messages back and forth between the two workers. Very easy. All right, so to summarize, that's going to allow you to have multiple ActionScript workers running at the same time. This is what's called a shared nothing isolation model, which means that when you're in one worker thread, you cannot access anything else that's in the other worker thread. You have to send messages back and forth, right? That's why it's called shared nothing, because they shared nothing in memory, but you have to send messages back and forth between the two. And we'll provide you some primitives that will make it easy to send objects back and forth between the two. But by default, nothing is shared. And you'll have access pretty much to all the APIs that you would, from your worker thread, that you would from your main thread. So you can do networking, you can do file system, you can do computation, you can do graphics as well if you want, all sort of different things you'll have access to. And then once your worker thread is done, you can just send the results back. That will allow you also to have your main thread, to have the UI where the user is going to be doing the interaction, and to make sure that that never gets blocked, right? That the user doesn't have to click on something and then wonders what's going on or why it's not reacting while you're, for example, downloading a big XML file and parsing it and so on. Now with this, the front of the UI will always be responsive, and you'll be able to do the heavy, expensive computations on a worker thread. So that's going to be pretty cool. And then another nice thing about this, like I said, given the evolution of the hardware, where more and more frequently we see multiple cores, even on the mobile devices, this will allow you to really take advantage of it and to build applications that will perform much better when there's actually hardware that has multiple cores. It will still work if you have a single CPU. We'll let the OS do all the magic to make that happen. But just from a hardware utilization point of view, it will work better when there's a hardware with multiple cores. So, are you guys still excited about this? All right. Cool. I got a few more things for you. So that's kind of some of the things that we're thinking about on the ActionScript VM side of things. I want to switch gear and talk about some of the things we're doing with video. So the first one is a new API that we're calling Stage Video. How many of you are already familiar with Stage Video? A few of you. OK. The others, I'm going to tell you why it's awesome and why you should totally use it. Here's what happens when you're trying to play some video on the desktop or mobile device. It's a little bit simplified because it's actually really, really complicated, but I think it's close enough to what's actually happening. So this is what happens every frame, right? For each frame that you display, all those operations happen. You start by looking at doing some network I/O to get the data from the network. You need to decode the stream and figure out what the geometry actually is. You're going to have to execute the ActionScript because that's running also with every frame. For example, if you have like a play bar or something like that, or if you're displaying some ads or any kind of other things that you're doing in addition to the video, that's going to have to run as well. We have to display the stage, what we call the stage, which is all the graphics other than the video that need to be displayed. Again, maybe the play bar and things like that. We have to do a conversion from YUV to RGB. YUV is the color space that's used for video, but then before we put it on screen, we have to convert that to RGB. And then we have to composite all of that, right? All the video content with the stage content, put them all together, and then finally send that to the GPU to be bleeded on screen. Are you guys tired already? That's all it takes for every frame, all the operations. exhausting. The sad thing is, all of that today, that's mostly done with the CPU. But again, a wonderful thing that's happening is that the hardware is becoming smarter and smarter. And nowadays, a lot of GPUs, again, both on desktop and mobile devices, they actually know how to start from the stream and do all the magic, all this in hardware, and display it on screen. And with stage video, you basically get access to that. So when using stage video, here's what happens. The CPU still gets the information from the network, right? That doesn't change. But then it hands over that information to the GPU directly and says, here's the stream, start doing your magic. The GPU is going to be decoding it, doing the conversion to YUV to RGB. And in the meantime, the CPU can also execute the action script and render the stage, and then blit everything on screen. So the reason why this is really cool is because now we're actually using the hardware better. We're balancing between the CPU and the GPU. You can see that there are some dead spaces here on the CPU, which means that other things can be happening. The CPU is not blocked. That also means that it's also using less power. Some CPUs will actually go to sleep even for very, very small interval of time. If they have nothing to do, they will automatically go into a low power mode, and that will help save the battery life. So that's something that can be really advantageous. Now, this works, as you see here, I said H.264, and the reason for that is because that's what the hardware typically supports. The hardware doesn't support any kind of codecs. They support certain type of codecs, and H.264 is the most common one that's supported. But the good news is that there's a lot of H.264 content out there. That's mostly that's probably what you're already using. That's what YouTube uses, for example. So you don't have to change your content a lot. Well, actually, you don't have to change your content at all to get the benefit for that. So that's stage video. Again, the benefits: reduced CPU usage, which will improve the battery life. You can also get a better frame rate by having the hardware do more of the work. You don't have to change any of the video. And the best news of all is that this is actually available today in Flash Player 10.2. So you can just go ahead and start using that API today. It's not even the future, or the future is already today. It's amazing. All right, now another thing that we're working on, and this one is one that we've never talked about to anyone, so you're going to be the first ones to know. Tell all your friends. We are working, we are working on a new video pipeline, a threaded video pipeline. That's what it says here, threaded video pipeline. So what does it mean? All right, so let's go back to our decoding of video and how it works typically. So this time I'm displaying 2 frames, and I've simplified a little bit the different steps. But you still have the execution of the action script, you still have to render the stage, you have to render the video, send the video to the GPU, and then you do that again for the next frame, right? Fairly easy. Now, what happens if in those about 33 milliseconds that you have to do all of this work, the action script, for example, takes a little bit longer, or the stage takes a little bit longer? Well, bad things happen. What's going to happen today is that some video frames and some stage frame potentially are going to have to be skipped, which means that your nice 30 frame per second video all of a sudden is going to become 15 or 12. Or worst of all, it's actually going to jump. It's going to be sometime 30, and then it's going to fall down to 12, and then go back to 30. And that makes for a really bad watching experience. So, are we going to fix this? Absolutely. We are going to fix this by introducing the new threaded video pipeline. And here's how it works. So, going back to just looking at one frame, right? Those are all the operations that happen to decode video in one frame. And with our new threaded video pipeline, what we're going to do is we're going to take advantage, again, of all the hardware that's there, and in particular when you have multiple CPUs, although that works also even if you have one single CPU. But we're going to divide up the work. So the action script execution and the rendering of the stage, that's going to happen on one CPU. And then in parallel, on another CPU, we're going to do all the networking I/O and the decoding of the stream. So those two things can happen at the same time. And then in the end, we just do the compositing and the bleeding. Which means now that if this guy or that guy take a little bit longer, that actually doesn't affect our ability to do all the video frames and to bleed on screen at the rate that we want. So that also means that if you have like a 30 frame per second video that you want to play, now your Swift movie itself, if you're not doing very much, that one could play at 1 frame per second, and that's okay. Because the video now will be playing at its own rate and will be displaying on screen at pretty much the maximum speed, which is going to be pretty awesome. So you also get benefits from the new threaded video pipeline when you're using stage video. When you combine the two together, it becomes magical. So this is what the stage video looks like, where you use the GPU to do some of the work, right? But now with the threaded video pipeline, when you combine the two, again, the work gets spread out between the CPUs that still do the action script and render stage. Some of the network I/O is done on the CPU, and then the decoding and the YUV conversion is done on the GPU. So again, you've spread out how do you do the work, and that allows you to avoid any kind of contentions, and again, that helps also with things like battery usage and all that good things. So at that point, that becomes pretty awesome. So threaded video pipeline, that's going to give you a smoother playback, better hardware usage. The beauty of it also is that you're actually not going to have to change anything to get the benefits from it. You'll just be able to use the existing content, existing code. Everything is going to work the same. It's just going to be work under covers that we do that will give you all those benefits. And that's something that we're working on to deliver to you soon. If you guys actually want it. Do you want it? All right. All right, that's good. I guess we'll keep working on it then. All right, so that's on the video side. Now let's have a look at graphics. So I want to talk to you a little bit about some of the things that we've been doing and some of the things that we're thinking about in the area of graphics. And the first one is about hardware rendering. So let me tell you a little bit what we've done here. How many of you know about the display list on the stage? OK, I'm going to stop there then. When you build something in Flash, when you build your content or your application, let's say that this is what you're trying to build here. Each object that you put on the stage is actually in a display list. That means that you have a top-level object that represents the whole stage, the whole thing that you're displaying. You're going to have a separate object, for example, for the text here. Another one that's going to be containing those two objects, the sun and the shape. And then one that's an image here, the sun that PNG file, and the shape, which is a circle, right? So that's what's called the display list. That's all the objects that are going to have to be looked at before something can be displayed. The more complicated this display list that you have, the longer it's going to take to do the rendering, obviously, right? So how does the existing software renderer that has been in Flash since forever actually works? That renderer is actually super, super optimized for what it does. It does it really as fast as it can. Time and again, we go back to it and say, you know, maybe we can optimize this here, optimize that there. We try to tweak it, and we find out that it's really been tweaked so much that it gives you all it can, really. The way it works is it's what it's called a retained renderer, which means that it's going to display all the pixels individually. And the way it does that using what's called scanline rasterization, which sounds complicated, but all it means is that it does it line by line, right? So for each line that needs to be displayed, it's going to look on that line and try to figure out which pixels, for example, have changed and needs to be updated. And then for each pixel, it's going to figure out exactly on the first go what the color of that pixel is. And the way it does that is by using the display list, and given a specific pixel on the stage, it's going to figure out which of the objects in the display list intersect that pixel, right? You could have some images that are behind or on top of each other, and that's going to influence the color of the pixel. So the trick is that you want to find, what is the object that's on top of all the others at this particular location, and then you just have to figure out, what the color of that object is, and you figure out the color of the pixel, right? Pretty easy, relatively easy. What? I can't hear you. Well, that's the way it works today. But wait, there's more. Now, if you want to use the hardware to do it, that can be really interesting as well. Now, the hardware works very differently from the way the software renderer works. The hardware, which is typically supported by something like an OpenGL API, is what's called an immediate renderer, which means that you build a scene, which is typically a lot of different triangles, and then you can move those triangles around and just ask the hardware to redraw it, and it's going to do it right away. You don't have to recalculate everything pixel by pixel. The way you do that, like I said, is by building what's called a scene graph, which means figuring out the different shapes that make your stage. If you have a curve, for example, if you have a circle, that circle is actually going to be made up of all sort of little triangles next to each other that are going to approximate the curve of the circle. If you have a bitmaps like this, that may be two triangles that each represent 1/2 of the image, right? That's your two triangles. So you build all those triangles because the hardware really is optimized to display triangles. It's easier if you only do one thing, right? So if you only have to display triangles, you can really optimize the hardware to do that. So you kind of have to transform everything into triangles, including bitmaps. And when a bitmap has been transformed into two triangles, that's what we call a surface. So you give the hardware all this data. At this point, what the renderer does is it transforms the display list that's there into all this set of triangles that the hardware can render, and then just ask the hardware to render it, which the hardware can do really quickly and with very little CPU usage. So that sounds fantastic, right? So here's the thing. We've tried that, and it turns out it doesn't work so great. We've tried it in a couple of different places. We've actually tried it with Flash Player on mobile. We've implemented that. We implemented the support for the hardware renderer on the Flash Player mobile. And what we found is that the benefits were not so great. And there's a couple of reasons for that. One is because with Flash Player in particular, we were trying to play just the content that's out there, right? Content that hasn't been modified or optimized in any kind of way, that's just been authored, the way people wanted to, so that it would work well with the software renderer. And we tried to apply the hardware renderer to that, and the results were a little bit disappointing. In some cases, things were a little bit faster than the software renderer. In some cases, they were about the same. And worst of all, in some cases, they were actually slower than the software renderer. What a shame. So why is that? Why is it actually slower sometimes when you render with hardware than when you use a software renderer, right? You would think that the hardware should be really, really fast, right? And one of the big reasons for that is because readback is very expensive. And what readback is when you need, in order to continue to render, you need to know what the composition so far looks like. You need to know, okay, all those shapes that are on top of each other, kind of what do they look like? And you ask the question of the hardware is like, well, before I can tell you the color of that pixel, I need to know what you've calculated so far. And that's going to require exchanging memory between the CPU and the GPU. And that is very, very, very slow, especially when it comes from the GPU to the CPU. The hardware is just not optimized for that at all. And unfortunately, in the Flash rendering model, there are quite a few things that in order to be implemented, need to have access to readback. There's things like filters and some effects and so on. So for content that's out there that hasn't been trying to avoid those things, that's where you can get into situations where actually using the hardware to do the rendering is actually going to slow things down. So that's pretty sad. So we tried that with Flash Player, and we also implemented that with Air on mobile. So both on iOS and on Android, Air actually has support for hardware rendering. Now, we didn't ship it with Flash Player because we tried it out, and we just saw that the results weren't very good. But with Air, we actually shipped it because the applications actually have control over it, right? So you can build your application, and then you can decide whether you're going to use the software renderer or the hardware renderer. There's a render mode flag that you can set, and you can say either CPU or GPU that will use one or the other. So you can try it with Air. You can build your application and ask for the hardware renderer to be used. And the reason that we did that is because with Air, you have a chance of actually modifying your content and trying it out and see if it actually makes things better or not, or to change your content so that it avoids the dreaded readback, right? Depending on how you put things together, that can trigger a readback or not. So if you do make use of it, you can get some good results. That's going to be very content dependent. But quite honestly, it is actually kind of hard to use as well, right? Trying to figure out when things go well, that's wonderful. But when things go bad and you see bad performance and you're not sure why, and it's probably something that you've done, something in the stage that's not quite set up right. But figuring out what's going on and fixing it is really, really hard. So that makes us a little bit sad. So one of the things that we're looking at to try to improve that, and again, you have the disclaimer here on the top, because that's something we're going to be exploring, and we may end up doing that or something slightly different. But what we're looking at is instead of having a full hardware renderer that does all the geometry and generate triangles for everything and all of that, we think that a better approach might actually be to mix the software renderer with a hardware approach. Meaning use the software renderer to render things like complex shapes and things with filters and all of that. But then use the hardware renderer to do things like very simple things like composition of bitmaps, which is something that the hardware is really good at, and that we think we can kind of like marry the two so that you get the benefits of hardware, but without having to do a lot of things to tweak your content. So that's kind of like the next thing we're going to try, and we hope that that's going to give some benefits to all the content that's out there. But we'll try it only if you guys think that's a good idea. So maybe it is a good idea. So let me show you some of the things that we've done. We started doing some experiments that go in that direction already. And those are performance numbers. That's a frame per second of some test content that we have. It's very simple test content. It's basically just a list that's running on a tablet, a list of, a text list that you can just scroll with your finger, right? It's very simple. And we built two versions of an app that does that. There's one that's a pure ActionScript version, that's the bars in blue, and another that's built using Flex. They do the same thing, just one is pure ActionScript and the other is Flex. And then, so those are the numbers with Air 2.6. And you can see the red line here. The red line is kind of like the frame rate that you want to have in order to have a decent user experience. If you get something less than 30 frames per second, it's going to feel like it's a little bit lagging behind, right? It's not going to be great. And as you can see, on iOS in particular, we had some challenges. That's what we like to call them, challenges. We were not quite reaching 30 frames per second. In fact, it was closer to 10 or maybe even less. So not great. So we looked at that, and we've applied some of the techniques that I was talking about before to try to leverage the GPU in a different way. And we've worked on implementing that in the next version of Air, which is called Air 2.7, which is going to be coming out really soon. Like I said, now that we have this more regular releases, every few weeks there'll be a new version almost. And this is what the result looks like with this new version. Do you guys like it? Yeah, we're pretty happy about that too. 60 frames per second, by the way, maybe if you're demanding, you're going to say, oh, come on, can't you do more? Well, it turns out that actually, no, we can't. 60 frames per second is the limit on iOS. iOS doesn't let you draw more than 60 frames per second. So we're going to the max there. So that's some pretty cool stuff. So again, hardware rendering. We have available today a hardware renderer that you can play with. That's available in Air, on Android and iOS. Just set the render mode to GPU. But you're going to have to adjust your content to really get the benefits of it. It's a little bit of an art at this point, but play with it if you feel like it. We're also going to be looking into using the hardware compositing like we did with Air 2.7 and doing that more broadly. Looking at using that with Flash Player as well. And then another thing that we're going to be looking at also is Stage 3D. How many of you know what Stage 3D is? All right. That's cool. I'm going to tell you all about Stage 3D then. Stage 3D, whose code name is Molehill. Now, how many of you know about Molehill? All right. Well, now you know both the code name and the real name of the feature. So the real name is Stage 3D, just like we have Stage Video, Stage 3D, right? There's a pattern to it. So Molehill Stage 3D is our 3D rendering API that we're going to introduce in a future version of the Flash Runtime. The reason why we call it Stage, just like for Stage Video actually, is because there's this idea of different planes. You have the main stage where you have your Flash 2D graphics. That's the main stage. And then you have stages that are other planes that are behind it. So you have one for Stage 3D, and there's in fact another plane behind the Stage 3D plane for Stage Video, right? So they kind of like stack up on top of each other. And then you basically punch holes, right? That's what this thing is here. You have a hole in the surface on top that let shine through either the Stage 3D or the Stage Video content, right? Make sense? It's kind of how Stage 3D works. Now, this is actually really complicated, and I'm not making it up. It really is really complicated if you're not into 3D. How many of you are 3D designers or programmers? All right, you guys are going to love it. Everybody else, not so much. Here's why. 3D is really hard. It's math, essentially, right? That's what it comes down to. You have matrices all over the place, and you have all sort of complicated operations and trigonometry and all of that good stuff. That's kind of like the fundamental of what 3D is all about. So with Stage 3D, we give you access to all of that. You have your basic all the different steps that you would find in a regular 3D pipeline, you have that in Stage 3D. If you want to do some interesting things, whoa. If you want to do some interesting things, like turning on the lights or building a fog. Let's say that you want to do a fog effect. This is actually what the fragment of code that does that. And you can see that you actually have to write what is basically assembly code in order to do that. And I kid you not, we actually invented that. We call that the Adobe Graphics Assembly Language, AGAL. And that's what you have to do if you want to implement things like shaders and so on. Now, you may say that we're crazy. How many of you think that I'm crazy for doing this? You guys are very generous. Thank you. Thank you very much. No, we're not crazy. The reason why we're doing this is because we are giving you an API that's as low level as possible, that is directly mapping to the hardware capabilities. And you can build other things on top of this API. You can build higher level constructs on top of that API that make it easier to use. But with that API, you have access to everything. You have very fine level control over the hardware, which is really, really cool. So those are some of the frameworks that have been built today on top of the Stage 3D APIs by some third parties that allow you to work at a much higher level. So you don't have to worry about the assembly language, and you don't have to worry as much about all the geometry and so on. You can see that there's a lot of them that are built to make it easier to build 3D content and 3D games and so on. But, and the thing that's really, really interesting about Stage 3D, which is why I was talking about it before when I was talking about graphics, is that you can also use it to actually display 2D content. And we have one framework that's been built so far that's called M2D, for Molehill 2D, that actually gives you 2D APIs, but that are built on top of Molehill. So even if what you're trying to do is some very simple 2D graphics, now you can use Molehill, and through Molehill actually get access to the hardware directly, which means you get like full hardware acceleration, the full support of the hardware and the GPU, but using it to do 2D graphics. So that's something that can be pretty cool. And one of the things I like to do is I'm going to show you an example of some of the things that you can do with Molehill. You guys would like to see a clip of examples of Molehill? All right, let's do that. That's some pretty exciting stuff. And as you saw on the demo, some of it was really 3D, but there were some examples also of some 2D usage. And by the way, everything was live, of course. That wasn't like pre-rendered or anything. It was all live interactive content. That's the kind of thing that you can do using the Molehill APIs. So really exciting stuff. So Stage 3D, like I said, very low-level API, but that's so that you can get direct access to the GPU, get amazing performance out of it. One thing, of course, is that when we built the Stage 3D APIs, we made sure from the very get-go that it was optimized for mobile, so that you don't need to have a high-end desktop PC to get those kind of performance, but that's something that you'll be able to get out of tablets and smartphones as well. 3D and 2D frameworks are available today, and we expect that there will be more that will get built, and you guys may build some of them, which will be very exciting. And Molehill is available today as a developer preview. That's available on Adobe Labs, labs.adobe.com. You can go ahead, download it, and build something with it today. So really looking forward to the really creative things that you guys are going to come up with it. We actually have a session tomorrow, Saturday at 9:15 in this room. Alex from Alternativa, who built some of the demos that you saw, will be here, and we'll talk to you much more about Molehill and how it works and the kind of things you can do with it. So if you're interested, go check it out. All right. So like I said at the beginning, what we're trying to do is we're trying to give you tools to make it easier for you to build your content and your applications, and then distribute them and make them available to all the platforms that you want. We're working really hard at making the runtime itself better in a number of different areas. On the ActionScript side, with the faster garbage collection, the faster ActionScript with the more efficient JIT. Introducing concurrency. You guys remember concurrency? Stage video, which is actually already shipping, the threaded video pipeline, hardware renderer, and finally Stage 3D and Molehill. So lots of different things. I hope that you liked the glimpse of what we're working on that I gave you. And I'm really looking forward to seeing what kind of great things you'll be able to create with all of this. And if you have some questions, I'll be happy to take them for you. Thank you very much.
Alô? Perguntas? Tem um aqui.
Ele está falando muito sobre tecnologias novas, o que a Adobe está investindo, né? Eu queria saber sobre a questão da indexação. Ele falou sobre a disputa do HTML5 e do Flash. Então, o HTML5 tem essa questão da indexação mais rápida. O que é que a Adobe está trabalhando com o Flash sobre isso?
That's a great question. We are working very closely with the major search vendors. We have a project that we call internally Ichabod, which is a technology that allows you to look at the Flash file. You send it to this, it's a server, and then it's going to give you all the text from that Flash file. It's going to also simulate the interactivity, so you can actually navigate that Flash file and do all the indexation and extraction of all the content of that Flash file. That's something that we've been working on, like I said, with the major search index vendors, so that they can incorporate that in their own search engines. And so that if you have a Flash that's out there, a Flash file that you've built, some content that you've built, you'll be able to actually search them and find the content in those files, just like you can with HTML. So. Perguntas?
Okay. Minha dúvida é mais sobre, não é nem sobre Flash Player, é mais para o desenvolvimento. Tem alguma novidade prevista para debugging no Flash?
Yes, that is something that we're looking at as well. We're working very closely with all our authoring tools, Flash Builder, Flash Pro, Catalyst. And one of the things that we're trying to do is to provide a better development environment. And one of the areas, there's a couple of areas that we're looking at. There's one that's specifically related to graphics. Because like I was saying earlier, when you have some complex things going on graphically, especially when the hardware is involved, it becomes difficult to figure out what's going on. So we're looking at providing some debugging tools that will help with that. And then there's another thing that we're looking at also that we're calling telemetry, which is a way of capturing much more information about the execution of your program. That can be all sorts of different parameters, could be memory usage, could be CPU usage, all sorts of different resources, and be able to capture that information and then display it inside the authoring environment. So that's another thing that we're working on as well. Again, if you guys, would you like to see more debugging tools? Yes? All right, thank you.
Oi. Aqui. Here. Uma das grandes promessas do player novo foi diminuir a diferença de performance entre plataformas diferentes, como PC e Mac. Pelo menos até agora, o que eu vi disponível no Labs da Adobe não aconteceu de verdade. Assim, a diferença de performance do Molehill no PC e no Mac ainda está gigantesca. Tem alguma coisa nova ainda que vai sair nesse player novo? Ou vai ser mais ou menos o que a gente viu até agora nos previews?
That's a great question. So you're talking about the difference in performance between Mac and PC?
Sim.
Molehill. Okay. So Molehill is designed to work with hardware and with GPUs. That's when it's going to work the best, obviously. However, there is actually a software version of Molehill, so that if you don't have the right hardware, you can still, see something. You can still render, but you're not going to get the same kind of performance. If you're seeing a problem, I suspect that what you are seeing is that the Mac hardware in which you're running on doesn't have the right GPU, the right drivers, or the right, whatever, to enable the hardware path. Or, not entirely impossible, it could be a bug as well. That's one of the things with hardware is that we test on a lot of different configurations, but there are so many of them that we may very well have missed something. So if you could contact me afterwards and let me know more detail about what you're saying, that's something we would definitely be looking into. We don't expect that there's going to be any significant difference between the Mac and PC if you have the right hardware, whether that's on the PC side, on the Mac side.
Aqui na frente. Minha pergunta é sobre o ActionScript em si, a sintaxe e a linguagem. Existe espaço para ela evoluir e existir um ActionScript 4 no futuro? Ou você acha que já a maturidade alcançou e estabilizou? O que você acha?
No, that's a great question. We are looking at evolving the language as well. I talked about float, for example. That's a small change. We have some other ideas as well. There are some other things that we want to look at. We've been looking at better syntax for events, for example, which are very common but kind of cumbersome to use and declare today. So we're looking at evolving the language that way. I don't know if we're going to call it ActionScript 4 or if it's going to be something more gradual, but definitely we're planning to evolve the language as well. That's one of the benefits that we have, being a language that we can control. That means that we can evolve it also much more quickly than we would otherwise. So if you have some ideas for some of the things that you like to see, let me know.
Great. Arno here. It's Igor. It's a pleasure to have you here talking today for the audience and explaining them the future of the Flash player and the Adobe Air. And during your session, I've noticed that most of the new features, the new rendering engines or whatever, and the new features that are planned for Flash player and Adobe Air is targeted for interactive and 3D. And one of the most successful features on both of these is rendering and then faster and faster. As an application developer, I didn't see any feature for RIA interactive application or RIA. So as you are in the Adobe, I would like to listen from you. What is the plans? What is the future from people that work with the Flex development for application, not only with interactive? Because, you know, from my perspective, it is to be what happens in the last 7 years, where Adobe, the Flash player, was only recognized as an interactive plugin, not an application platform for developers, for real developers. So I would like to know if Adobe and your team has any plan for application development, any future release supporting ActionScript for server-side coding, or more collectible things, or more frameworks based on the application, not only with the interactive development for 3D, for rendering, for games, or whatever. That's my main question.
Absolutely, that's a great question. So here's the way that we're thinking about it. We're trying to keep the runtime itself, which means Flash Player and Air, as small as possible. We're trying to give you like the basic functionality that you need that interacts the most directly with the hardware and the rest of the operating system. And then think of it kind of like as an onion, right? There's like this little core that's we're trying to make as small and as fast as possible. And then on top of it, there are multiple layers of increased functionality that can be built on. The work that we're doing with Stage 3D, that's a perfect example of that, right? We're providing you like a very low-level access in the runtime, and then ActionScript-based frameworks on top of it that are going to provide additional functionality. So the same is true for application development. In the runtime itself, we focus on the core functionality, and then we build the additional features on top of that in frameworks like Flex that gives you all the added functionality that you might want. So I haven't talked about Flex today, but that doesn't mean that we're not doing anything with it. We're actually doing a lot of things with Flex. We have a new version of Flex that's coming out really soon now. That's going to have great support for mobile devices. That's really been optimized for touch support and with all sort of new components that can work well on mobile devices. That is easier to skin as well. So we're making a lot of improvements there. We're working with a lot of partners like Salesforce.com, for example, who build a lot of enterprise software and would need to have very complex enterprise applications that they build. And we work with them also on making sure that both at the Flex level in the framework and in the runtime, we have the right functionality for what they need. So yes, this is something that's important, and we are continuing to work in that as well. But today I just focus on like the lower level runtime.
Arno, alô. Aqui. Eu teria uma dúvida para comentar a respeito em relação à acessibilidade que o Flash dá atualmente. A colega falou a respeito da indexação, e a minha dúvida seria mais ou menos assim, qual é a estratégia que a Adobe está adotando agora, por exemplo, para usar o Flash em dispositivos móveis, já que a Apple tem uma rixa com a Adobe e não permite que o Flash seja incorporado. Enfim, qual a direção agora que a Adobe tem dado em relação a essa acessibilidade para determinados dispositivos móveis, como, por exemplo, a da própria Apple, do iPhone?
Right, so we are supporting iOS. We're not supporting Flash Player in Safari on iOS because, as you know, we have a difference of opinion with Apple on that subject. But we are supporting Air on iOS. So you can build Flash-based applications using Air, using Flash Builder, using Flash Pro, and you can publish them on the App Store. We already have thousands of applications that are today on the App Store built with Flash. You just can't tell that they're built with Flash because there's nothing that tells you that, but they're out there and you can install them and run them and all of that. We'd like to have Flash Player on iOS. We think that that would give you access for people who use iOS devices to more of the content that's out there. But at the same time, with mobile devices, we see also how important applications are, which is a way that a lot of people actually get access to more interactive content. And so, we're happy that, using Air, you can get access to, as a Flash developers, to those devices and by building applications. And we plan to continue to support iOS, definitely on the application side.
Arno, we have just a quick question from the chat audience out there. His name is Attila, and he wants to know when the molehill is actually going to be released.
So it's available today as a developer preview on labs.adobe.com, and it's going to be available soon as a release product. We don't have a date that we've committed to yet, but part of it will depend on the feedback that we get from this developer preview. As you guys use it and as you report problems, if you find them, we'll make sure that we build a great product before making it available to everybody else.
Boa noite.
A última, pessoal, a última pergunta.
A última pergunta é, perdão se eu não escutei a resposta, porque parece que o amigo perguntou sobre o iOS e também sobre acessibilidade. Sobre acessibilidade, o que está sendo feito no Flash Player e quando a gente vai poder considerar que estamos fazendo um site em Flash que é acessível e que um leitor de tela pode ler tranquilamente e quando a gente vai ter um guia sobre como fazer da melhor forma para ser acessível.
Accessibility in the context of a Flash Player or Air, do you mean? With Flash Player. So we have some accessibility support in the Flash Player today. That's actually something that we're working on as well. We know it's not perfect. We know that there can be some improvements made there, and we're working on it as well. If you want, you can come find me afterwards. That'd be interesting to get more of your feedback on that. That will help us actually figure out where we need to spend the time. So definitely something we're interested in.
Então é isso, pessoal. A gente vai encerrar por hoje. Obrigado, Arno. Thank you, Arno.